Welcome to this presentation. Here's what we're going to talk about today. Charmed by Linux, haunted by VMs. Kudos to the marketing team for coming up with that snazzy title. Living a container-first lifestyle at the edge kind of hints at the topic being how to think about application management at the edge, maybe with a particular focus on the benefits of containerization. And just because I've had a conversation or two of the more awkward kind in the booth, I don't mean physical shipping containers. I'm talking about Docker or Podman software containers here, just to get that behind us. I'm Carl. I'm the CTO of a company called Avaza. To no one's surprise, we actually have a solution to the kind of topic that we're talking about here today, and I'll give you some pointers to how to find me after the presentation. First, really brief, because I've done this many times, but it usually helps. I'm going to be talking about edge computing. And the simplest way I know of defining edge computing is to say that it has to do with having very few computers, but in very many locations, which is kind of the polar opposite to how I think about the cloud paradigm, which is to have usually an insane amount of computers, but in very few locations. And I will argue in this presentation that this is sufficiently different. The edge is sufficiently different from the cloud that it warrants a little bit more thinking than just to apply maybe the learnings we have from the cloud. The edge is different. And that drives a number of really interesting conversations, of course, with our users. This is a terminology that was actually launched by Gartner. And it has really helped us in many conversations. Our users come from one of two directions. On the left side, we have something we call cloud out. That means that this enterprise or this company or this application was kind of born in the cloud, but it has a couple of components that actually fits better if it's allowed to live closer to sources of data or users. So people that are actively looking to shift applications out of the cloud and onto the edge for a variety of reasons. Usually has to do with response times, might have to do with data sovereignty, might have to do with the cost of actually pushing lots of data into the cloud. They're usually well incentivized to think hard about which parts of applications to move to the edge. The good thing here is that most of those customers are already fully containerized. Some of them run on VM-like infrastructure, like EC2s in Amazon, but most of them are already well on their way in using containerization as a universal packaging format, and it makes a lot of sense to them to stay with that as they move certain components to the edge. Now on the right side, we have IoT in, and that's a very interesting and kind of emerging market, where there are applications that have been running at the edge for a long time, but they've usually been kind of stovepipe or deeply integrated into existing exotic operating systems and things like that. Think of OT in manufacturing and other places, where there's a realization that Linux is a thing now, and that containers seems to be a generally useful way of packaging applications. So they arrive at that topic by actually looking at what most engineers know of today. And if people are born and raised with the cloud and hired into the IoT environment, they will default to Linux and to containers. So both of our users are really pushing hard towards actually being kind of container first, think about applications in terms of containers for their next generation distributed infrastructure. So what does that mean, though? Of course, this comes with a number of side effects, or as we would like to think of it, things to think through, because there's much more to containerization than just tar file or just a particular file format. It comes with a whole ecosystem of tooling that can be very, very useful to think about or think with as you kind of move towards this here problem space. Because it's going to drive kind of your path to success. So I'm going to do a little presenter trick now. I'm going to pull up what looks like a little self-evaluation form. I'm going to talk through them and tell you what they're about, but I would like for you to all think about which bucket, if any, you fit into, because yes, I'm going to do a raise of hands after those two slides here. Here we go. Okay, so on the left side, this type of customer is kind of what I mentioned first. The driver here is that applications must be uninterrupted, meaning if the internet has a problem or the cloud has a problem, there's a class of applications that needs to run anyway. May have to do with safety, may have to do with transactionality, for example, point of sale systems in retail. May have to do with a lot of things that just simply won't be able to deliver the kind of uninterrupted availability if you run it off-prem and in the cloud. That comes with its own set of really interesting obstacles, right? Because what they usually do is that they start with the cloud and then, again, move towards the edge. And that drives a set of wishes or things they need to kind of gain a golden path towards this deployment scenario. For them, again, autonomy is really important. In terms of the wish list here, multi-tenancy, meaning being able to host a variety of applications and even application teams on the same edge infrastructure. And the third one, broadly speaking, means the ability to leverage on existing developer and operations tooling, being able to integrate what they already have with the edge infrastructure. So that's the left side. On the right side, we have companies that wants to drive a faster feature speed, kind of hinting at the old kind of deeply integrated and maybe even real-time operating system solution towards a more distinct, a more clear distinction between infrastructure and the applications to be able to gain better release cadence. Heavily tailwinded by, for example, models, AI models, where upgrading your software can't happen with a USB stick, must happen remotely. So the obstacle here is, of course, to break out of what they have today and work towards a more normalized IT-like environment. And the wish list that we observe from them is usually, again, integration with the toolings that they have, just the ability to do remote updates of applications, their associated configuration, and the operating system layer, of course, comes as a requirement to that. And something that they usually underestimate is that it's wildly different to manage and operate applications if they run in thousands of locations as opposed to maybe 2 locations. So the definition of green or a healthy applications is more nuanced when you run it across many locations, out of which maybe a percentage is offline at any point in time. So you have to think about your comprehensive kind of day 2 operations features. Okay, so those are the 2 buckets. So for those of you who this applies, please think about which one you belong to, if any. Because of course they match what I just mentioned, cloud out and IoT in. Okay, so the obligatory raise of hands. Anyone that feels like a cloud out user in the audience? Good, 6 or 7. Interesting. IoT in, any IoT in fans here? 1, that's good for 3, 4. Pretty even split. Interesting. In terms of numbers, we see a little more, a little faster on the IoT in. They seem to be more under pressure to get out of that kind of exotic ecosystem into more mainstream tooling. But again, a number of the kind of more technical pressure points on the cloud outside is what's driving that. All right, now we've kind of said that. Here are the 2 types of users that are usually impacted by the path that's being picked. We meet them often enough that if you've been in our booth before, you've heard of them. We've lovingly given them names. On the right, we have an IT engineer called Patrick McEngine. He loves IT infrastructure. He builds it with passion, and he wants things to be robust and easy to manage. On the left, we have Applifair developers. She's in charge of the actual application workload. She cares way less about the intricate details of the infrastructure, but she cares a lot about how comfortable it feels to manage the life cycle of her applications on that kind of distributed infrastructure. Kind of spoiled a little bit by the cloud experience and has very little patience for other types of more hard experiences when it comes to the edge. The important part with her is that she's usually tied to a line of business. She drives the value stream. So in that room, she's actually the one that brings enterprise value. So eventually, we think she's going to be calling the shots. What they share is a need for a set of, let's call it fundamental principles. I've mentioned a few of those before. One of them that seems to be most pressing for many of our users is the separation of concern. Applifer wants to be able to lifecycle manage her application on top of Platric's infrastructure without manual involvement. She wants a self-service experience. She doesn't want meetings when she's deploying an application or an updated version of an existing application. She also doesn't want to swivel chair away from the tooling that she has just because it's the edge. She wants to stay with whatever it is that she's already running. And at the foundation of this, of course, is that she wants the speed to go up. She wants to be able to deploy faster. She wants to be able to monitor more efficiently. She wants to be able to beat expectations with the applications running at the edge. So in well-formulated or well-organized enterprises, this becomes kind of a common goal across the board. Now, if you take that with you and lean heavily on the fact that a lot of these teams are now used to and invested in containers, we can start thinking about what that means. The really cool thing, and we've spent quite a bit of time on this over the last couple of years, is that, again, containers are not just a file type. It is a means of actually starting and stopping applications. It's a means of actually reaching log files. It is a means of detecting outages. The container ecosystem gives us various types of probes. There's a lot of tooling ahead of deployment that just works with containers. And containers are, if you look at them, pretty thin containers. That's why they're named that. The default being, of course, just a small set of binaries usually, 1 or 2 daemons or something like that, with a couple of files, maybe a database. But there's nothing stopping users from leveraging the tooling that they have, not only for applications, but we see a lot of uptake to do clever things with containerization of AI models, which in inference-based environments is what changes. The actual systems don't change much for AI applications, but the models do very rapid changes. At times, we have users that does model updates several times a week, while the applications almost never change. And maybe more importantly, there is good support for actually putting virtual machine images in containers, so you can actually access, or you can actually support maybe that single or simple VM-based application that needs to be kept alive, but you can slot it right into your container ecosystem. It's literally a matter of embedding a QCOW file, for example, into a container image. And by doing that, you get all the versioning, you get the startup, you get the logging, you get actually VNC access. So by doing that, you actually can snap out of hypervisor-based side silos and actually lean heavily on the container ecosystem, which we've found many, many times to be very, very efficient and actually reduce the operational overhead and increase the reuse of the IT operations tooling that users usually already have in place. So let's have a brief look at what that looks like. Here we go. Here we go. All right, so this is the dashboard, if you like, or the UI for the product that we provide. It caters to both, if you remember them, Platric and Applifer. So let's take a brief look at the Platric worldview first. So let's think about an infrastructure person here. Infrastructure people usually have clusters or locations as the central object or the central abstraction. So it's really natural that in this case, on the left side, we have a list of sites. Sites, in our terminology, consists of hosts, one or more. We can see that most of these locations have a single host, like Barcelona here. That tells us what kind of resources is available here, what kind of operational state do we have. And actually, since in this case Platric supports several Applifers, we can also see that there are indeed applications running on this particular site. But the important part here is to understand that at the heart of this abstraction is a list of sites. And what Platric here has also done is that he's added a couple of labels to this site, because he has an intricate understanding of the details of the infrastructure, so he knows that there's actually a GPU available here. So he makes that a label automatically so that eventually applicators that require GPUs can match against such criteria. So a comprehensive understanding of the hardware and software we're running on, combined with labeling mechanisms, allows Plattrick to present the appropriate parts of the infrastructure to Applifer, who then gets to deploy her applications on top of this. So if we switch to an Applifer worldview, you will see the opposite. She thinks in applications. So here's a list of the applications she's in charge of. And this is a little bit of a spread out typical demo floor setup, but she has an MQTT broker. She has an image classifier. She has a VM-based Ubuntu server because she needs the entire Ubuntu operating system here. And she has a simple visitor counter. And we can see that the image classifier is already up and running in 6 locations. Now, that's the way she thinks, right? So she knows that, okay, these are the locations I'm running on. I can see my version here. I can see the status. And I can drill into, for example, Paris and see if I can actually take a look at the operational state of the applications here. So what she can see down here when this catches up is a drill down perspective of the instance of her container application, right? So she can see that it's up and running, doesn't have any restarts, that it actually passes all the probes. She can open a terminal if she wants into the actual container because she doesn't get to have host access. She gets container access because she only cares for their application. And she gets also to see logs. So we can use the container, if you like, infrastructure for sending distributed queries to particular applications in particular locations to collect the logs that she needs. So she gets all the tools that she needs for this. And this is a really simple application with a couple of components. And she does the same thing with this Ubuntu VM server. So same thing here. She can drill into looking at what that, oops, now it works. What that actual application looks like. In this case, it's a started VM in a container image. And again, we can reuse the restart counter, we reuse the probing, and we can even reuse the logging mechanisms. And if we want to, we can also open a terminal to the actual VM, if that's something we desire, and log in and do whatever we want. Again, in the VM, not the host operating system. So it's built on the same abstractions across, like you would have for a containerized native application. And the way it looks like to deploy something like this, based on what I mentioned about the infrastructure before, independent of whether it's an application, an AI model, or a combination of those, or a VM, is to express what we call a deployment specification. And this, again, goes across payload. So in this case, we call this the visitor counter deployment. And this is a declarative formula. So our more advanced users actually has this in Git, right? And actually uses Git ops tooling to push this towards our control plane. And then by doing that, they get to decide and control the life cycle of the applications. So we name it, and we point to an application, we point to a version of this application, and we use site labels. So we now know that this needs a GPU available label. And so the system will figure out that that's actually 6 locations. We're idempotent, but we're not running on any of them. So this is a very straightforward process here. We create it, and we can watch it come alive. As we distribute the container images first to local registries, because we want to be outage resilient, so we always need the container images hosted locally. And then we start them. And knowing the quality of the network, oh, here we go. So now we're up and running. And we can do the same thing here. We drill into Tokyo and see if we can get an operational overview as slow as the others. What it would show you is the same thing. It's just that this time it's not a VM. It's a bare metal, or if you like, a naked containerized application. And of course, many other things related to the fact that this is a container application first worldview. For example, maybe I want to see the query logs from all sites where this is running, because this is a manageable set of container registries. I can use our querying mechanism and say, I want logs since 3 minutes from all locations where it's running, and it will start feeding me that kind of output from the logging subsystem for these applications. And again, this is without any actual instrumentation. This is actually what the container ecosystem gives us. So, in order to summarize this, we clearly see that independent of which direction our users come from, they've arrived at the conclusion that containers is the most likely packaging format, again, not only for applications, but for other assets, including keeping up with legacy or foundational applications in virtual machines. So independent of whether it's cloud out or IoT in, container seems to be a durable way of thinking about the applications. But knowing or understanding whether you're cloud out or IoT in will kind of describe your path to success in our mind, particularly reusing some of the institutionalized, let's say, experience this far will allow you to kind of keep ahead of things that may not be super evident initially or early on. Our good friend security is always interesting, and day 2 operations is the same. And again, if you need things like VMs and maybe other legacy assets, of course you should, right? But think and see if you can actually leverage the container ecosystem to actually do that in a harmonized fashion with the kind of the rest of the assets that you have, and you can actually reap the benefits of the tooling that's part of the container ecosystem. So those are the 3 things that I really would like to leave you with, and of course, I would love to open for some questions. I am sure we have a minute. Who's first?
So the question is, why not K8, why not Kubernetes and directly containers?
So yeah, so someone who knows that our implementation actually doesn't use Kubernetes for the edge. There's 2 reasons. In order to build what I showed you here, the way we've kind of looked at doing that with Kubernetes will require Kubernetes, but somewhere between 15 to 20 additional components. And we would like to scale down to single board computers. And if you do that, you simply won't be able to even start your first application because the infrastructure side of things, i.e. Kubernetes, and the 15 or so CRDs will have actually consumed your entire CPU budget. The second thing is that it's extremely hard to provide a coherent experience if you build things with Kubernetes and other things. Just think about configuration around the plethora of concepts that you have if you need multi-tenancy. So the kind of operational overhead of just configuring the infrastructure components to us was prohibitive when we did that. So because you asked, we run directly on Docker or Podman, increasingly actually Podman.
Yeah, hi, thank you for taking my question. So you kind of skipped over another architecture paradigm, which we call serverless, right? Represented by AWS Lambda functions and queues and similar setup on Azure, which extended to the edge, let's say on AWS, it's through greengrass.
Yes.
So what's your take on containers versus this serverless paradigm?
Yeah, good one. So my hot take is that that's a very partial solution that's more related to the runtime. What's really impressive about it is, of course, the small amount of manifests you need, like just the code. What it doesn't give you is things like standardized logging, standardized versioning, standardized observability, standardized tooling for error fixes. So in my mind, until we get a little further down the path of the entire standardized or open life cycle for them, which is heavily hosting dependent right now, I think it will stay a very powerful abstraction in certain types of infrastructure rather than a general format or general operational model for an entire set of infrastructure. But I think there's some interesting movements in the kind of the open standards bodies around trying to address more than just, you know, the syntactic format for the languages as they're defined, you know, by the vendors. So I think there's some ways to go. Yeah. Let me just leave you with this, with a big thank you and a meme. And please come by booth 252, both to talk to me, get a demo. We also brought Swedish candy. I'm out of Stockholm, Sweden. For those with teenage kids, knows the power of Swedish candy. So come by and pick up a bag. Please. Thank you.